Also connected to the ground. The RTC is connected also on the board and connected on the 5-volt Arduino pins. The RTC is connected on the Arduino with SCL and SDA pins on the Arduino. The LCD displays the units using the set cursor function on the code. Also the RTC and the DHT for the temperature saves the value on the code. Then the code can display their values on the LCD. For the analog gear, its variables is changed by moving the gear. So backward, it's supposed to be R. Forward, it's D. When we press the analog, it's P. The analog is connected, its Y and X coordinates connected to the board by A0 and A1 pins on the analog and the Arduino board. SW press is connected to digital 22 pin on the Arduino board also. The potentiometer is a resistor that is connected here to control the brightness of the LCD. We have a light sensor that is connected to a resistor 1k ohm and the LED LED. The sensor senses the light around and sends a signal to the code, which receives the signal and set the LED signal to be high, to be turned on. And if the light sensor felt that there is a light, so it sends signal to the code that the LED must be set to be low. Okay, that's my part, and thank you.
Hello, I am Ahmed Abdelazim from Team 21. Here we have our feature that is emergency brake. So we have the ultrasonic here. We have ultrasonic sensor here, which has input signal twig and output signal echo. We have also a buzzer here that connected to the Arduino board, and we connected that ultrasonic to the Arduino and take 5 volt from that Arduino. We have like we will calculate the distance between the sensor and any object or obstacle behind this sensor. If the trig detects any signal from the sensor, he will calculate the distance between the car and the obstacle, and if the distance was less then it will stop the motors of the car, and the buzzer will give us a sound like this. Okay, and after that sound, the motor will stop the car.
Hello, my name is Ahmed Mustafa Koshlan, 40-2884, MET CSEN student. My port was MP3 module. We get a hardware MP3 called DF Mini MP3. Uh, we we used the speaker for the playing sounds to hear sounds. Uh, it was really not easy course. It was it's not easy as it seemed. We used semaphores in it. Uh, we take semaphores in previous and next and previous. We used to take semaphore and give it at the end of each task. You cannot in our module we cannot play or next when we play or next when it's pause. We you can of course next or previous when it's on. We face a lot of problems. One of them it's for the speaker cannot deal with high sound. Next or previous when it's on. We face a lot of problems. One of them it's for the speaker cannot deal with high sound. We cannot figure out this problem. So we got bigger speaker, bigger speaker. First Stanford wasn't a really easy task, as it can block all tasks around it, so we cannot pause or next pause a play or next. So it was a hard module.
Hello, my name is Karim Shamatiya, 40-5512 in the faculty of MET. So my part in this project was the scheduling part. So at first what we did in this project is that we connected each component or module or task, should I say, separately on the breadboard and tried them out. And then when we made sure that they worked out, we moved on to the next thing. So when all was done, it was then time to schedule. But we faced a problem there as usual. So scheduling was not functioning as well as we wanted to at first, because so basically we had priorities. We set priorities for each task, but then it would not work out. Like the whole thing would freeze out and crash. But so we decided to add a delay, I think of 100 milliseconds or so, and it did work better, but still, like the MP3 module was not working, and it was not functioning as we wanted it to. The whole core was not, it was like basically very, very slow. So we decided to change our whole initiative and move to round robin. So we would dedicate like a few seconds, I guess 100 seconds or so, to each task to perform, and then the scheduler would move on to the next one until everything was done. And it worked very, 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 very well. As for the software, we used FreeRTOS, which is an RTOS, like a real system for scheduling. Basically semaphores, that works. And that was it, I guess.
وانا بص كاتب هنا